Chapter 6.2, Multiplying and Dividing Rational Expressions. To multiply or divide rational expressions, use the following rules. A over B times C over D equals AC over BD. We just multiply the numerators of the fractions and multiply the denominators of the fractions. An example, 1 over 2 times 3 over 8 would equal 1 times 3 is 3, and 2 times 8 is 16. A over B divided by C over D equals A over B times D over C. When dividing by fractions, we multiply by the reciprocal of the second fraction. So change the divide sign to a multiply, and then flip the second fraction upside down. Then we just multiply like normal, multiply numerators. A times D is AD, multiply denominators, B times C is BC. An example, 3 over 8 divided by 1/2 equals 3 over 8 times 2 over 1, which equals 3 times 2 is 6, 8 times 1 is 8, and then we can reduce that. 6 and 8 can be divided by 2. We get 3 over 4. Multiplying and dividing rational expressions. Step 1, factor the numerator and denominator if possible. Step 2, state the NPVs. Step 3, multiply or switch the division to multiplication and then multiply. And step 4, simplify. Express the product in simplest terms and state the NPVs. We have D over 2 pi R times 2 pi RH over D minus 2. Step 1 is to factor, but looking at our expression, there's nothing to factor, so it just stays as it was. D over 2 pi R times 2 pi RH over D minus 2. Step 2, state the NPVs. For multiplying expressions, we are looking for NPVs in the denominators. The first denominator is 2 pi r. The variable is r. If r is equal to 0, then 2 times pi times r would equal to 0. So r equals 0 is an NPV. The second denominator, we have d minus 2. When is that equal to 0? When d is equal to 2. So our NPVs are r equals to 0 and d equals 2. Step 3 is to multiply. We want to multiply together, so numerator times the numerator, d times 2 pi rh would just be 2 pi rh d, and then the bottom we'd have 2 pi r times d minus 2. Step 4, simplify. 2 pi r h d over 2 pi r d minus 2. We can divide out 2 pi r from top and bottom, and we are left with h d divided by d minus 2. And notice we cannot divide the d on top and on bottom because the bottom one is d minus 2. It's not a factor of the bottom because we can't factor out a d from the 2. Y squared minus 9 divided by r cubed minus r times r squared minus r divided by y plus 3. Step 1, factor. Starting with the left fraction, y squared minus 9, that's a difference of squares. Factors to the square root of the first term, y and y, square root of the last term, 3 and 3, 1 plus, 1 minus. The bottom, r to the power of 3 minus r. We can factor out an r there. We get r times r squared minus 1. Next fraction, r squared minus r. I can factor out an r there. we get r times r minus 1. On the bottom, y plus 3 can't be factored. So do I have this factored? Well, we can actually factor this one further because now that's a difference of squares. So fully factored, y plus 3, y minus 3 divided by r times difference of squares. So first term is r in both factors. Second term is 1 in both factors, 1 plus and 1 minus. And then our second fraction is r times r minus 1 and y minus 3. Step 2, NPVs. Looking at the denominator on our first fraction, we have r times r plus 1 times r minus 1. We want to know when is that equal to 0. We break it up into each of the factors. When is r equal to 0? When r is equal to 0. When is r plus 1 equal to 0? When r equals negative 1. When is r minus 1 equal to 0? When r equals positive 1. And then we look at our other denominator, y minus 3. When is that equal to 0? That should be y plus 3. When is y plus 3 equal to 0? When y is equal to negative 3. Our NPVs then are r equals to 0, 1, and negative 1, and y equals to negative 3. Step 3, multiply. Multiplying is pretty easy. We just write all the factors together. So we usually put, if we have a single variable, that usually would go at the front. So I'm going to put r and then r minus 1 and then y plus 3 and then y minus 3. And then on the bottom, we have r times r plus 1 times r minus 1 times y plus 3. Step 4, simplify. We can divide out the r's that are on top and bottom. We can divide out the r minus 1 on top and bottom. We can divide out the y plus 3 on top and bottom. So what are we left with? We have y minus 3 on the top and r plus 1 on the bottom. That's our simplified rational expression. Determine the quotient in simplest form and state the NPVs. So division, a little bit harder, but same process for the most part. Step 1, factor. The top is a basic trinomial. We need two numbers that multiply to negative 7 and add to negative 6. That would be negative 7 and positive 1. We get c plus 1, c minus 7. The bottom of that first fraction, c squared minus 49, that's a difference of squares. It factors to c plus 7, c minus 7. The second fraction, c squared plus 8c plus 7, it's also a basic trinomial. We need two numbers that multiply to 7 and add to 8, which would be 7 and 1, c plus 7, c plus 1. We want to factor our bottom, c squared plus 7c. There's just a common factor of c there. We factor that out, c times c plus 7. Step 2, our NPVs. When we're doing division of fractions, our NPVs are a little bit different. For the second fraction, because originally this is our denominator, but when we kiss and flip, when we multiply by the reciprocal, this is going to be our denominator. So we have to do NPVs for both the top and the bottom of the second fraction, and then also, as normal, the bottom of the first fraction or any other number of fractions that are in there, okay? But any fraction that you're dividing by, so you're going to be multiplying by the reciprocal, you have to state NPVs for the numerator and denominator for those fractions. Looking at the bottom of the first one, we have c plus 7 times c minus 7. We want to know when that's equal to 0, which is when c plus 7 equals 0, which is c equals negative 7, and also when c minus 7 equals 0, which is c equal to 7. And then in the next one, we have for the denominator c times c plus 7. We want to know when's that equal to 0. Well, it would equal 0 when c equals 0, or when c plus 7 equals 0, which is when c equals negative 7. We already had that from our first denominator. Then looking at the numerator of the second fraction, we have c plus 7 and c plus 1. We want to know when that's equal to 0. It's equal to 0 when c plus 7 equals 0, which is c equals negative 7. Again, we already had that one. Or when c plus 1 equals to 0, which is when c equals to negative 1. Then our NPVs, we had c equals negative 7, c equals 7, c equals 0, c equals negative 7, c equals negative 7, and c equals negative 1. So the only ones we had that were different was 0. We had 0, negative 1, negative 7, and positive 7. Step 3 is to do our kiss and flip, so multiply by the reciprocal. We have c plus 1 times c minus 7 divided by c plus 7 times c minus 7. Multiply that by our reciprocal, which is now c times c plus 7 over c plus 7 times c plus 1. Put that all into one fraction. Doesn't really matter the order of the factors, but typically we would put that c at the beginning, mostly so it doesn't get lost. We have c times c plus 1 times c minus 7 times c plus 7 divided by c plus 7, c minus 7, c plus 7, c plus 1. Step 4, simplify. We can divide out our c plus 1 on top and bottom. We have 1 c plus 7 on top. We can divide out 1 c plus 7 on the bottom. And we have a c minus 7 on top and bottom that we can divide out. What we're left with is just a c on top, and on the bottom we're just left with c plus 7. Next one, factor. A squared plus 5a minus 14. We need two numbers that multiply to negative 14 and add to 5. We get a plus 7, a minus 2. 7 times negative 2 is negative 14. 7 plus negative 2 is 5. Bottom, a squared plus 8a plus 7. Two numbers that multiply to 7 and add to 8. We would have 7 and 1 would add, positive 7 and positive 1 would add to 8 and multiply to 7. Next fraction, a squared minus 4a plus 4. Two numbers that multiply to positive 4 and add to negative 8. If they multiply to a positive but add to a negative, they both have to be negative. A minus 2 times a minus 2. Negative 2 times negative 2 is 4, and negative 2 plus negative 2 is negative 4. And on the bottom, 8a squared minus 6a, we can factor out 2a. We get 4a minus 3. Step number 2 is our NPVs. Remember, this is a division question, so we need to look at the NPVs for the denominators like we normally would. But we also need to look at the NPVs for the numerator of the fraction that we're dividing by, because we're going to flip that fraction and then that numerator will become a denominator. Looking at the first denominator, we have a plus 7 times a plus 1. We want to know, when is that equal to 0? Well, this is equal to 0 when a is negative 7, and this is equal to 0 when a is negative 1. Our next denominator, 2a times 4a minus 3, when is that equal to 0? The first part is when a equals to 0, and the second part we can calculate. 4a minus 3 equals 0 when 4a equals 3, which means a equals 3 divided by 4. And then the numerator of the second fraction, a minus 2, a minus 2. Well, they're both the same, so it's going to be the same value. This is equal to 0 when a is equal to 2. We then have negative 7, negative 1, 0, 3 over 4, and 2 as our NPVs. Step 3, we're going to multiply by the reciprocal. A plus 7 times a minus 2 divided by a plus 7 times a plus 1 times the reciprocal of the second fraction, which is 2a times 4a minus 3 over a minus 2, a minus 2. Put it all into one fraction, putting the 2a in front. 2a, a plus 7, a minus 2, 4a minus 3, all over a plus 7, a plus 1, a minus 2, a minus 2. Step 4 is to simplify the rational expression. We can divide out a plus 7 on top and bottom. We can also divide out a minus 2 on top and bottom. Then we're left with 2a times 4a minus 3 over a plus 1 times a minus 2. That's our simplified rational expression. Last example, simplify, identify all NPVs. We have a division and also a multiplication. Same process though. First step, we want to factor. 3x plus 12 has a common factor of 3. We get 3x plus 4. 3x squared minus 5x minus 12. 3, 5, and 12, there's no common factor, so this is a complex trinomial. I'm going to factor that over here. 3x squared minus 5x minus 12. Multiply the a and the c value together. 3 times negative 12 is negative 36. We need two numbers that multiply to negative 36 and add to our b value, which is negative 5. Those numbers would be negative 9 and positive 4. I'm going to do the box method. Top left box is 3x squared. Bottom right box is negative 12. Negative 9x and 4x go in the other two boxes in any order. Factor each row and column. First row, 3x squared and negative 9x. The first term, 3x squared, is positive, so my common factor will be positive 3x in this case. Second row, 4x and negative 12. Again, first term is positive, so my common factor is positive, and it's 4 in this case. First column, 3x squared and 4x. Again, it's positive, and in this case it will be x. And then second column, negative 9x and negative 12. The first number in the column, negative 9x, is a negative, so my common factor will be negative. And then negative 9x and negative 12, it would be negative 3. The factored form is then 3x plus 4 and x minus 3. The second fraction is 12 over 3x plus 4. We can't factor 3x plus 4. And the third fraction, 2x minus 6, we can factor out 2. It becomes 2 times x minus 3. On the bottom, x plus 4 we can't factor. Step 2, we need to do the NPVs. Remember, we have a division in this question, so we're always going to look at the denominators for all of our fractions. But we also need to look at the numerator for any fraction that we're dividing by, which in this case is the middle fraction. The numerator in this case is just a whole number, so there won't be an NPV, but we just need to make sure that we check that anytime that we're dividing. First denominator is 3x plus 4 times x minus 3. When is that equal to 0? This part, 3x plus 4 equals 0 when 3x is negative 4, which means when x is negative 4 over 3. And then x minus 3 equals 0 when x equals 3. The next denominator is 3x plus 4, but we already did that. We had that one right here, so we don't need to do that again. We already have the NPV for that. And then the last one is x plus 4. When is that equal to 0? When x is equal to negative 4. Then our NPVs were negative 4 over 3, 3, and negative 4. Step 3, we want to do our multiplying. We have 3x plus 4 over 3x plus 4 times x minus 3. We're going to kiss and flip this fraction, so it becomes multiply by 3x plus 4 over 12, and then multiply by 2 times x minus 3 over x plus 4. Then we put it all into one fraction with our coefficients at the front. So we have 3 and 2. So 3 times 2 is 6. Then we have x plus 4, 3x plus 4, and x minus 3. And on the bottom, we've got a coefficient of 12, and then we've got 3x plus 4, x minus 3, and x plus 4. Step 4, we want to simplify. We can divide out x plus 4 on top and bottom, x minus 3 on top and bottom, and 3x plus 4 on top and bottom. So all we are left with is 6 divided by 12, which reduces to 1/2. All that work just to get down to 1/2. That brings us to the end of lesson 2 for chapter 6.